Hello children. Today I have taken a topic real numbers. This is a class 9 topic. So before getting to the concept, let's look into the number system. The first one. So what are natural numbers? Natural numbers. So the numbers are in the form of, they start with 1, 2, 3, 4, so on, infinite. So natural number starts with 1, 2, 3, 4, so on, infinite. So these numbers are denoted with the letter capital N. And these are also called as counting numbers. Counting numbers. Why we call them as a counting numbers? Because if I have given a set of things, from where we get started counting, not from the zero, right? We'll start counting from a 1, 2, 3, 4, and so on. So that's the reason natural numbers are also called as counting numbers. And the next one is, so yeah, here, what is this? This basket contains 5 mangoes. If somebody has eaten these 5 mangoes, then how many mangoes left in the basket? Empty. Yes, so 0 mangoes. So in this number system, 0 came into the picture. So those numbers were called as whole numbers. Whole numbers. These are denoted with the letter W, capital W. So along with this natural numbers, 0 also included. 0, 1, 2, 3, 4, so on, infinite. Okay. Yes. Now the next one is, if we do 1 plus 3, we get 4, right? So if we do 1 minus 3, what do we get? We get a negative 2. So yeah, because these are unlike symbols. Unlike symbols get subtracted and greater number sign follows. Here the greater number is a 3 and 3 is having a minus sign follows. So there also, along with the 0, 1, 2, 3, 4 in our number system, we have even negative numbers. So negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, so on up to positive infinity. So the number starts from a negative infinity. All negative numbers, 0, and all positive numbers. So these together called as integers. We call them as integers. So these integers are denoted with the letter capital I or Z, capital Z. So how do we represent these integers on the number line? We have learned in previous classes, right? So if we have taken this as a number line, we used to represent 0 in the middle and all negatives are towards to the left side and positives are right side. Okay. So these are called as integers. Integers are nothing but all negative numbers, 0, and all positive numbers. Now, yeah. So what about, see, for example, I have a pizza. Okay. So this pizza is made into 4 parts. Okay. So now 2 parts are eaten by me. This 1, 2, 3, 4. These 2 parts are eaten by me. Means how can we represent this? 2 out of 4, right? Somebody has just 1 part. So how we will represent this? 1/4. So along with this negative numbers, positive numbers, 0, we do have a fractions here, right? So yes, exactly. I'm going to talk about the rational numbers. Rational numbers. What are rational numbers? Rational numbers are represented in the form of P by Q, where P is in the numerator and Q is the denominator. P comma Q belongs to integers here. Okay, so it could be a negative number, 0 or positive number. So P and Q could be any number here. And also Q should not be equal to the 0. What happens if I have taken Q is equal to 0? 2 over 0. 2 by 0 means it's nothing, no value for this. 0 by 2, we have a value 0. So 0 by anything we can represent. But 2 by 0 does not exist. There is no value for the 0 which is situated in the denominator. Okay. So rational numbers are always expressed in the form of P by Q, where P, Q are belongs to integers, I for integers, and these numbers are, and Q is not equal to 0. So here in this rational numbers, addition is possible, subtraction is also possible, division is possible, and multiplication is possible. When we add two rational numbers, we will get the result as a rational number. And also when we subtract, we get it as a result also rational number. Okay. So now, yes, let me show the real numbers. Let me coming to the main point, real numbers. Right. Yeah. So this is the real numbers diagram. So in this real numbers, what I have mentioned, whatever we have discussed, those names are seen, right? Natural numbers, whole numbers, integers, rational numbers. All natural numbers belongs to the whole numbers family. All whole numbers belongs to the integers family. All integers are the part of the rational numbers. So real numbers means what? Real numbers means it is just combination of rational numbers and irrational numbers. We all have seen and learned about the rational numbers. Coming to the irrational numbers. What are irrational numbers? A mathematician, Pythagoras, wondered representing root 2 or constant value of a pi. Okay, so irrational numbers. Numbers which can't be represented in the form of a P by Q are called as irrational numbers. Numbers which can't be represented in the form of a P by Q are said to be as a irrational numbers. There are infinite irrational numbers in between each and every number. For example, if we have drawn a number line, this is the 0 and this is the 1. In between 0 and 1, we have a infinite numbers like root 2 we can represent, root 3, root 4, root 5. If we have a represented 0 to 4, in between we have a infinite rational numbers, root 2, root 3, root 5, root 6, root 7, and also pi. So in between the 0 and 4, we have a infinite number of rational numbers. Infinite rational numbers can be placed. No rational numbers can be represented as a irrational number. No rational number become a irrational number. No irrational number can become a rational number. The combination of a rational and irrational both together called as a real numbers. Okay. See, for example, what do we represent 1 by 2? Everybody knows it's a 0.5, right? It's a 0.5. 1 by 3, let's divide this and check. 1 is going to divide with the 3. So put a point, 0 times, so you can place 1, 0, 3 3s are 9 here. 10 minus 9 gives 1. and already point exists, so you can place one more 0. Again 3 3s are 9 and 1 0, 3 3s are 9. So again and again we are getting the same reminder, and again we are getting the same question. So what do we represent here? 1 by 3 as 0.333, so on. That is equal to 0.3 bar. So we can mention whatever the decimal is repeating, on top of it we can mention as a bar. So if we mention a bar on one number, it's nothing but the 3 is repeating. Okay, this is the repeating decimal. Okay. Next, 1 by 4. How can we represent a decimal form of the 1 by 4? If we divide and check, we will get 0.25. Okay. Then what about 1 by 5? 1 by 5 is nothing but 0.2. 1 by 6, 0.1666, so on. So this can be written as 0.16 bar. 1 by 7, 0.142857, so on. 1 by 8, 0.125. 1 by 9, 0.111, so on. That also can be mentioned as 0.1 bar. Okay. Next, 1 by 10, we all know this 0.1 simply. So if we have a check all these divisions, there is one thing common. We can conclude one answer. See, this is 1 by 2, right? 1 by 3, leave it. 1 by 4 also can be expressed as a 2 square, right? 2 into 2. And coming here, 1 by 5 is just 1 by 5. And 1 by 6 is represented as a 2 into 3. 1 by 7, it's a non-terminating, right? 1 by 8 also we can write it as a 2 cube. Okay. 1 by 9 also again non-terminating. And 1 by 10 is a terminating. This we can represent it as a 2 into 5, 1 by 2 into 5. So if we have seen all these divisions, we can observe that the numbers which can be represented as a 2 power or a 5 power or both 2 into 5, product of 2 into 5. So these are called as terminating decimals. Terminating means after the decimal point, there is no continuity. Terminating means the decimal places have been end here. Okay, if you have been observed, what are the numbers you should have? 2, 5 or both 2 and 5. If your denominator contains 2, 5 or both 2 and 5, then the decimal places will be terminating. So this division is terminating. And if there is some other number, apart from this 2, 5 and 2 and 5, there is some other number like a 3 or 7 like that, then they are non-terminating. We can check 1 by 3 is there. So it is non-terminating. Non-terminating means after the decimal, this 3 is go on continual. There is no end for this decimal. In the same way, we can check here also. We can observe here also. 1 by 5. See what I said. Our denominator should contain 2, 3 or both 2 or 3 or both 2 or 5 or both 2 and 5. Okay. We can have 2 also. We can have 5 also in the denominator, or sometimes we can have both 2 and 5 also. Then those division is only the terminating. So here also 1 by 6. We can write 1 by 6 as 1 by 2 into 3. Along with the 2, we have a 3 also here. That's the reason it is non-terminating. Keep on getting the decimal places here. And 1 by 7 here also. So we don't have a 2 or 5 and 2 and 5. So this is also the repeating one. Non-terminating. And 1 by 8, we can represent this as a 2 cube. So it's just, we can write this 1 by 8 in the form of a 2 power something. So this is also terminating. And 1 by 9, we can't put it in a 2 or 5. So this is non-terminating. And 1 by 10, so this is terminating. We can represent 1 by 10 in the form of 2 into 5. So this is also terminating. So what it says, rational numbers are nothing but terminating, which contains 2 or 5 or both 2 and 5 in the denominator. And the remaining all other which are non-terminating, they are all said to be as a irrational numbers. Irrational numbers are therefore non-terminating and non-repeating. Non-terminating, non-repeating. So these type of numbers are said to be as a irrational numbers. Example for irrational numbers are root 2. The value is 1.41421356, so on. This root 2 is here non-terminating. There is no end for these decimals. If you keep on do division, you will keep on get the quotient. Your quotient is going to becoming much. So this is a non-terminating. And also pi value. We used to mention 22 by 7, right? If you divide this 22 by 7, we get 3.1415926, so on. So this is also non-terminating. This is also non-terminating. Okay, non-terminating and also non-recurring. Recurring means what? Same digit again and again repeating means recurring. See, in previous case, we can observe that here 1 by 9, if we divide 0.1111 is repeating. So that's the reason we kept a bar on that, the repeating decimal. So this is recurring. Recurring means reoccurring the same number. But irrational numbers means what? Non-repeating, non-recurring. Here the decimals doesn't repeat and the decimals does not end. So this type of numbers in the number system is called as irrational numbers. Hope you understand the irrational numbers concept. For the solutions of the further exercise, keep watching my channel.